So are the slides visible? Am I audible? Anyone please
Yes,
respond?
sir. Yes. Yes, sir.
Okay,
Audible.
okay, very good. Okay. Now, good morning to all of you. Let's start other parametric model today. Yesterday I had told that many parametric algorithm point yesterday and in previous classes we have already discussed about LOC, that is the size. Two important examples of parametric or algorithmic models are size and FP. FP stands for function point. Size we can measure also by what LOC already we have discussed in the previous classes. The drawbacks of LOC we have seen. So that's why nowadays very few people they use LOC as a measure for size. Most of the software developers or software practitioners they use function point for this estimation of the size of the software. So now let's see. Today is a little bit important and it will be a little bit difficult to understand. Please try concentrate and try to understand. Today will take a little bit more time. We have to finish up this. Today we'll continue with our previous discussion on parametric models. As I have already told you, there are two good examples of parametric models. Those are size or LOC and function point. Okay, two examples of parametric models we have discussed in the last class. One is LOC, another is function point. LOC, it has several drawbacks we have already discussed. Today we'll discuss about the other model, that is function point. So there are several kinds of function points. We'll discuss first on Albrecht or IFPUG function point. Okay. Other function points like Simpson's function point, etc. We'll discuss later on. Today we'll discuss Albrecht or IFPUG function points. So this IFPUG function point perhaps was proposed by the great scientist Albrecht. The full form of IFPUG I will say after a few minutes. So parametric models for size we have discussed in the last class. As I have already told you, there are two the metrics or two parametric models for size were used. One is LOC, another is this function point. So this function point is an important example of parametric model. Initially, the function points they were used to estimate only the size or the lines of code rather than the effort. But nowadays also people are using function points for effort. So now let's see how does it work. So this parametric model takes two inputs. So while we are computing the function point, so this model, this is a parametric model, it takes two inputs, the number of file types and the number of input and output transaction types. So I am saying the how the originally the function point while this model was proposed, it was used to compute or to estimate the LOC rather than the effort. At this time, the model it was taking two inputs, the number of file types and the number of input transaction types and number of output transaction types. Then by using some mathematical equation, by using some mathematical model, it was estimating what will the system size. It was predicting the system size. Okay. So now let's see that what parametric models are available for size. We shall examine four important parametric models for size more closely. Number one is Albrecht or IFPUG function points, then Simpson's or Mark II function points, then cosmic function points, and the last one is very, very important, COCOMO 81 and COCOMO 2. These are also parametric models for size. Using COCOMO 81 and COCOMO 2, we can also compute, we can also estimate the size. So today we will discuss about only the first one because these are very large topics. Today we will try to finish this Albrecht IFPUG function points. IFPUG stands for Internal Function Point Users Group. Okay, so there is a group named international. This was known as International Function Point Users Group. So they have proposed this metric FP. That's why this is, and this was mainly headed by this Albrecht. So that's why this is known as International Function Point Users Group. What are the purpose of this group? The main purpose of this group is to promote and encourage the use of the function point for estimating the size. Another purpose of this group is to develop consistent and very accurate accounting guidelines. Those can be used by various software developers. Several benefits of this group are there, like they can network with other counters. IFPUG counting practices manual is available, which you can easily use to compute or estimate the function points. There are so many research projects they are providing. It's hotline newsletters also they are publishing. They also give some certification like this. The extent of use is like that. Member companies include all industry sectors, not only software industries. Over 1,200 members in more than 30 countries. They are involved in this International Function Point Users Group. Okay, this is a little bit brief about IFPUG. Now, as I have already told you, today we will discuss only the first function point, that is Albrecht IFPUG function point analysis. Now, Albrecht, he has worked at IBM. While he was working, he needed a way of measuring what is the relativity productivity of different programming languages. Okay, there are so many programming languages at that time, like Fortran, Pascal, C, C++, Java, etc. He needed a way of measuring what will be the relative productivity of different programming languages. Yes, last class I have already told you the definition of productivity, isn't it? Sorry, Nicholas. So I have already told you yesterday about what this definition of productivity. So here Albrecht needed a way of measuring what is the relative productivity of the different programming languages. He also needed some way of measuring the size of an application without counting the lines of code. That's very important, because in case of LOC, you have to count one by one. He needed some way how he can measure the size of any application without counting the lines of code or without counting the code line by line. Okay, that's why he thought, let's develop a new way to find to measure the size of an application without going for counting the lines of code. So he identified actually 5 parameters. So after doing a huge amount of research, he found that if we can estimate these 5 parameters, then perhaps we can estimate the size. He identified 5 parameters. What are they? He counted the occurrence of each type of functionality in order to get an indication of the 5 parameters. Albrecht counted the occurrences of each type of functionality. Why? In order to get an indication of the size of an information system. So he counted the occurrences of each type of functionality. Okay. Basically, his approach is a top-down approach. And yesterday I have discussed about top-down approach and bottom-up approach. So basically, it is a top-down approach. So let's say the reason why IFPUG, this group thinks one should not use LOC. I have already told you so many drawbacks of LOC in the last class. Let's summarize again. Why IFPUG people think one should not use LOC. Number one, the lines of code tend to reward profligate design and penalize concise design. Isn't it? It penalizes concise design. I have already told you, if you are using a high programming language, then you have to write smaller number of code. But if somebody has written in a traditional language, assembly language or machine language, he is writing more line of code to do the same thing, then you say that he is better productive. So, because his LOC is more. So IFP, these people thought that the lines of code LOC, it tend to reward profligate design and penalizes concise design. If you are doing some concise design, then it will be penalized. They will think that your productivity is low. There is no industry standards like ISO or otherwise for lines of code. So far, no industry standard like ISO or any other standard is there for lines of code. Lines of code cannot be used for normalizing across platform languages or by organizations. Okay, so maybe inside one organization, okay, but lines of code, it cannot be used for normalizing across different platforms, across different languages, or by across the organizations. Some 4GL do not even use lines of code. You know examples of 4GL that where the specification can be directly executed. Those are 4GL. Example is structured query languages. So some 4GLs, they do not even use this metric lines of code. Lines of code can be misleading. I have already told you different just programming language you will use, and it will just misleading. It cannot take the use of advantage of reuse, etc. Lines of code can be misleading. These are some of the drawbacks. That's why IFPUG people thought that one should not use LOC. Then how do function point overcome LOC problems? So I have already told you several problems of LOC. Let's see how do the function points overcome the LOC problems. Number one, the function points are independent of the language or tools or methodologies used for implementation. You may use C, C++, Java. This function point metric, it is independent of the language used, tools used, or methodologies used for implementation. That's why it overcomes one of the major drawbacks of LOC. Function points can be estimated early in analysis and design. In LOC, you can almost you have to wait for the coding is over. Then you can count the code. But function points, they can be estimated even early in analysis design from the SRS document or from the design documents. You can directly compute you can directly estimate the size. So you need not wait till the code is over. Since function points are based on the user's external view of the system, so non-technical users of the software, they have a better understanding of what function points are measuring. Okay, these function points, they are based on what? The user's external view of the system, how the user will perceive it externally. So no need of technical knowledge. So non-technical users of the software or the end users, they have a better understanding of what the function points are measuring. They can easily understand what things are measured by the function points. So in this way, function points, they overcome the LOC problems. Now let's quickly see what are the objectives of function point counting. It measures the major objective of function point counting is to measure the functionality that the user requests and receives. Okay, it can be used to measure the functionality that the user requests and receives. Another objective is to measure the software development and maintenance independently of technology used for implementation. Whatever technology, whatever programming language you may use for implementation, but it can measure the software development and maintenance. Okay. Another objective of function point counting is to measure the software development and maintenance independently, not dependent on any other thing. Independently of what? Independently of the technology that you are using for implementation. You may use for C, C++, Java, or whatever technology. It is independent. You can easily estimate the software development effort or the maintenance effort. It is very simple enough to minimize the overhead of the measurement process. By using function point, it can be seen of the. It is a consistent measure among various projects and organizations. LOC cannot be used across. It cannot be used to normalize the estimation or so among various organizations, but it is a consistent measure among various projects and organizations. These are some of the objectives of function point counting. Then next, when should you count the function points? When you can count, or when you should count the function points? Number one, at the very early stage, as I have already told you, during the requirement analysis stage or design stage, you can count the function points. No need to wait for the coding is over. Early and very often you can count the function. You can quantify what delivering the requirement specification page. It is more control under you. So the sooner you can quantify what a project is delivering, the sooner you can estimate about the project size or effort, the sooner it is better control. Under IFPUG 4.1, there are several rules and guidelines. These rules and guidelines, they make it possible to count the function points once the requirements have been finalized. Okay. So in IFPUG 4.1 version, there are several rules and guidelines. These rules and guidelines, they make it possible to count the function point once the requirements have been finalized, once the SRS document is prepared. The estimate of size in function points can be refined continuously throughout the development cycle. It's not that once you have done it is fixed. No, it can be refined again and again. So the estimate of size in the function points can be refined continuously throughout the development cycle. It is not fixed. It is not constant. You can refine it. You can modify it. You can change it. Function points should be recounted throughout the development process. Okay, the function points, they should not be fixed. Once they are counted, you should not fix them. Function points should be recounted throughout the development process. It can measure scope creep and breakage. Okay, the function points, it can measure the whether you have creeped the scope, whether you have what to go beyond the scope and the breakage. It can measure the scope creep and breakage. So these are the steps which will be used for function point computation. Let's see what are the steps. First, you have to identify the counting scope and application boundary. What is the scope of your application? What is the boundary of the application? Identify the scope and boundary of the application. First step is identify the scope and application of the boundary of the application. Then you count to what are the count the data functions, then count the transactional functions. From this, you can find out the unadjusted function point, because this function point needs some adjustment according to some cost drivers. So then determine the unadjusted function points. Then what you do, determine because these are, you can say, just like not these are not normalized, these are unadjusted. We have to use another factor called as a VAF, stands for value adjustment factor. There's a formula I will show you. Then you determine the value adjustment factor. Then you multiply those two things. Unadjusted point should be multiplied with the adjustment factor. This will give you the adjusted function point count. Okay. Here you have found out the unadjusted function point. Then you have also determine the value adjustment factor. Multiply these two things. Then you will be able to calculate the adjusted function point count. Okay, these are the overall function point computation steps. I will take some examples to illustrate this. But before going to the example, I have to say what are the exact what components. In the first slide or in the previous slides, I have told that Albrecht had identified 5 important components. What are the 5 important components? These are the 5 important components based on which you can compute the function point. So Albrecht had identified 5 important key components. Those are external inputs, external outputs, external inquiries, logical internal files, and external interface files. Those are the 5 things, maybe slightly rewritten in different books, but these are the important things: input, output, inquiry, logical files, and interfaces. Basically, these are the 5 components based on which you can estimate the function point. Please remember this. This we have to use. Okay. Now let's define one by one. What is the first one? External input. So what do you mean by external input? Very simple. These are the transactions which update the internal computer files. Okay. So by the external input means what input you are giving to your computer system. These are the transactions which can update the internal computer files. We call them as external input. External output means here external outputs are 2 types. Then here we'll see the external output types. These are the transactions, just normal output. These are the transactions which extract and display data from internal computer files. It is a very simple output which can display the data from the internal computer files. So generally it involves creating the reports or printouts kind of things. Next is the external inquiry types. Inquiry means just query. You can say query. So the user initiated transactions which provide information but do not update the computer files. These are just queries. Search a book, show me the search a book, or search the availability, or search the schedule. Those kind of things. They will just search the database maybe, and they can give some report only. So in external inquiries, they are also known as external queries. These are user-initiated transactions which only provide some information, but maybe through a table lookup or data search or database search, but they do not update the computer files. Normally, the user inputs somewhat data that guides the system to be to the information the user needs, isn't it? How you get the answer to a query? Normally, the user inputs some data. Initially, he inputs some data which will guide the system to the information the user needs, or to the which answer to the given query it will be produced. So it will be dependent upon the data that the user gives. Normally, the user inputs some data that guides the system to the information that the user needs. So this is the external inquiry or external query. Then is files, or we can call them as more popularly logical interface files. So these files, they equate roughly to a data store in system analysis. So files means normally they correspond to the data store. Normally they equate roughly to a data store in system analysis terms. So they are created and accessed by the target system. So these files, they are created and accessed by the target systems. Then you will see the interfaces. We call them as external interfaces file systems, or EIF. So external interface file, it represents the data that is received from where? From a data store which is actually maintained by a different application. Okay, this is what that's why I'm saying your logical interface file, but here the word I am using external, which is external. You may see while you are discussing about this railway information system, you are booking something, but it is accessing maybe one external file, the train database, that you may consider. I'm sorry, the external interface. So while you are discussing booking a ticket, so it has to interface with what? Maybe the bank gateway. And if you say interface files, if it is interfacing with the train database or the schedules, that file that will be external to the system. So it is very much clear external interface file system types which are external to the system. So external interface file, it represents the data which are retrieved from where? Which are retrieved from a store which is not mentioned, which is not maintained by that system. Rather, which is actually maintained by a different application. So this is known as external interface file types. Very easy. So again, those definitions I have put every definition in one slide. That is very easy. You will read yourself. So whatever I have told, five parameters, 5 components. The definitions are written here. The like input means it is usual type that enters the extra bound of the software system being measured. Isn't it? Which enters your data and it adds or changes data in a logical internal file. This is very simple. These things are quite easy. Please read yourself. And they almost you know what is input, output, file, interface, queries. You know, we need not explain more. You can refer later. So whatever I have told, I have just given the definition for each one. That also external what it do access data from where? That comes from outside the application boundary, isn't it? External input, like online entry. This transaction comes to what the update customer information, and then it comes to the customer info file. So this external input, it processes data that comes from where? That comes from outside the application's boundary. This is an example here. It is shown. This is the definition of external input. So this is how we have discussed this external input, and similarly you can read yourself external output, inquiry, and then easy things. You please read yourself. No need to discuss in detail. Those are easy things. Please read yourself. Just one second. Hello. Hello. मुझे क्लास अच्छी अधाने पर now quickly take whatever items I have told, that 5 components are required. How can find out the function point, how you can estimate. It's a very rough example, simple example. After that, I will take more concrete examples. This is an example of placing purchase orders. And you know, in case of while you will place some purchase order, what do you require? What will the input data items? The date, supplier number, the product code, the quantity, how much you require, the date on which you require. This is the date on which you are placing. This is the date on which you require the items. Output is, if you will give those things, it will automatically generate a purchase order. And what is that? What is the name of, what is the number of the purchase order? Purchase order number. What entities are referenced? Like product is an entity, purchase order is an entity, supplier entity, purchase order item of output data items, number of entities read or updated, NA. This is for each functionality. Then what you do? How many functionalities are there? Then you add these up for the whole system. Add whatever the for each function. Suppose there are 10 functionalities. Then add these values for the 10 functionalities to get these 3 values for the whole system. It will give you the number of input data items for the whole system. We call as capital NI. Number of output data items, NO, and number of entities read or updated, NA. You will get for the whole system. We'll take a small example. Suppose in a SRS document, there are 12 requirements, A1 to A12. A1 requirement or A1 functionality contains 10 inputs, 2 outputs, and 4 entity accesses. That means you are reading or updating 4 entities. Requirement A2 contains 10 inputs, 3 outputs, and 6 entity accesses, like this. So how I can estimate the size like this? So I have to first find out the number of input data items, number of output data items, number of entities read and updated for each functionality. Then you add up these values. So I have found out these values for each one, each functionality. 12 functionalities are there. These are small ni. So on adding this, we get capital Ni. These are small no. After adding, you get capital No, and these individual values are small ne. After adding, you get capital Ne. So if these are the values are there, then you can develop a mathematical model, like some constants or weights you can add. So like 120, some factor might be 2 or 3, then 100 plus 120, again 2 or 3 plus 60 into 4, like that. So you have to basically found out some multipliers or some constants, multiply with these individual values, then you add them, you will get what will the what function point or what will the total system size for this given application. So now let's see, as I have already told you, you have to multiply these individual things with some multipliers or constant values. So Albrecht had found out some multipliers. They call them, people call them as Albrecht complexity multipliers. So he has identified there can be 3 possibilities for the complexities: low complexity, medium complexity, and high complexity. So he has also found out some from his experiment. He has found out some constants which can be assigned to the complexities, like external input type. If it is very low, its value is 3. If the input is of medium type, value is 4. If the inputs are very highly complex, then the value is 6. Similarly, if the output type it is very low, then its value is 4. If it is medium, its value is 5. It is high, its value is 7, and like that. He has found out some values. So if in the examination no regarding complexity, nothing is mentioned, you have to assume it is medium. Please remember, in the examination a problem may come. If the complexities are specially mentioned, you have to, the values will be given. If the complexities are not mentioned, you have to assume they are medium, and this medium complexity you remember. Like that is for input, the complexity is 4. For output, complexity is 5. For inquiry, complexity is 4. For file, complexity is 10. And for interface, complexity is 7. So if it is given, you take these things. If it is not given, you have to assume the medium complexity values. Okay. Now again, somewhere if it is not given about this, but the file type I have given already given 7, 10, 15. But in some cases you will see they will be just writing like how it is based on some data types, then and some record types. So how to determine whether this is, you suppose in a problem the file is described by using the number of records it has and the number of data each record has, then how to determine whether it's low, medium, and high. So here average means medium. So if number of there is only one record, then and if that record contains less than 20 data types, then low. In between 20 to 50, then low type. If that record contains more than 50 data types, then it is of average. If your particular file contains 2 to 5 records, because I am again saying file is a collection of logically related records. Record is a collection of some logically related data. So that's what I am explaining this way. If you don't say 20 to 50 is average and if it is greater than 50 it is average. If your file contains more than 5 records and there are less than 20 data types, then it is average. If it is more than 20 data types, then it will be of high complexity. And the values for low, average means medium, low, medium, and high. The values for low, medium, and the high complexity for the files are given here, 7, 10, and 15. Accordingly, you can use those values. Okay. Now we have already taken those things. We can take various examples. We'll start with simple examples. Suppose a logical internal file might contain data about the purchase orders. Okay, there is a logical internal file. It may contain data about the purchase orders. These purchase orders might be organized into 2 separate record types. So there are in that file there are 2 records are there, 2 record types. One, the main purchase order, and another is, we'll say, so one is the main purchase order details, namely the purchase, and this what record purchase order, it will contain what? It will contain the purchase order number, supplier reference, and purchase order date, and the details for each purchase order item. So another is what? Another is the we have to contain the main purchase order. Then for each purchase, then in the purchase order, what are the items? So one is for the purchase order, another is for each item. So the second one is then the details for each purchase order item specified in the order. So what data will be present in this record, like the product code or the item code, the unit price of the item, and the numbers order. That means the details of the items. So that means we have seen this file consists of two records, and this purchase order record may have having 3 data here: purchase order number, supplier reference, and purchase order date. Purchase order item, it also has 3 data types or 3 data like product code, unit price, and number ordered. So we can conclude that the number of record types for that file would be there for almost 2. One is purchase order, another is purchase order item, and the number of data types will be how much? For this purchase order 3, order number, supplier reference, and purchase order date. Here 3, and here also 3 for the item. The product code, unit price, and number order 3. So 3 plus 3 is 6. So according to this, now we have to go to the previous table. There are 2 records and 6 data items. 2 records means this, 6 data items means less than 20. So what will be its type? The complexity will be of low. So complexity, file complexity is low means what will the value? See, for the file complexity is low. Low complexity is what value I should consider? I should consider 7. So in that way, given a problem, you have to identify what should be the complexity for the particular component by looking at these tables. Okay, so that's why I can say that this would mean that according to the according to the previous table, this file type will be rated as what? Low, because only 2 number of records are there. And this would mean that according to the previous table, the FP count would be how much? 7 for this file. So 2 and the total number of data is 6. So this entry I can take low, and for low it is 7. In that way, you will be able to do this. So in the examination, If it is other than medium, that is low and high, the values will be given in the question. Otherwise, if it is medium, you have to remember these complexity values. Now, let us quickly take one small example. Okay, so but before going to that example, there must be how to compute. So anyway, so now let's see how to compute the complexity, or how to compute the function. If you are given, these are the components, these are the complexities, then what you have to do? These numbers you have to count. How many external input type, how many output type, how many inquiry, how many internal file, how many interfaces. Then they have to be multiplied with what? Say there are 3 input files, 3 into 4, plus 4 output files, 4 into 5, plus 7 inquiry type, 7 plus 4, plus 2 input files, 2 internal files, 2 into 7, plus 3 queries, 3 interfaces, 3 into 7. Like that, you will get the total function points or the estimation of the function point. I am taking quickly a small example. Please try to understand. Suppose you have to develop a software called for spelling checking. So the spell checker accepts as input. What does it accept? A document file and an optional personal dictionary file. So it accepts 2 things: a document file and an optional personal dictionary file. The spell checker lists what? It lists all the words which are not contained in either of these 2 files. That means either the document file or the personal dictionary file. The user can make a query for the number of words processed and the number of spelling errors which are found at any stage during processing. Basically a spelling checker kind of software. So now let's see. We have to estimate what will be the function points. So my software is a spelling checker dictionary. What the user is supplying, the errors found, he may send an inquiry like how many numbers of errors found. He may send an inquiry regarding the words processed. He may send this document file, and he may send the personal dictionary. I have already told 2 files: the document file and one optional personal file, personal dictionary. Okay. Then what we will do? What output the user may expect? Words processed, isn't it? The number of words processed message, the number of errors message, how many errors you are getting, the number of reports on the misspelled words. So these may be the outputs. So now we have already seen that there are 5 components. These are the 5 components: that input, output, inquiry, files, and the interfaces. Now we have to use those, and the complexities we have known. Using this, we will find out what? We will find out the estimated function point. Now let us analyze this thing. From the given problem, you can see how many inputs. You can easily see there are 2 inputs. One is there are 2 inputs. One is the document file, another is the optional personal dictionary file. So 2 inputs you are giving. How many outputs? You can see there are 3 outputs: number of words processed message, number of errors message, and report on misspelled words. So 3 outputs. That means error report, word count, and misspelled error count, or you can say the average. Sorry, these are 3, and you can see that these inputs are not very low or very high. So we can consider these inputs are similar. Number of processed words and the number of spelling errors, isn't it? How many? You see 2 inquiries: number of processed words and number of errors. Number of processed words and number of errors. It is also assumed that they are of average type or they are of medium type. Then one internal file is there. What is that internal file? You can see dictionary file is the internal file. So one internal file you are using. And how many external files or interfaces? So two, the document file and the personal dictionary. This is the standard dictionary and this is the personal dictionary. So 2 external files, document file and the personal dictionary. Even if something not mentioned, you have to interpret yourself. Personal dictionary you are giving, but the system must have a dictionary. Every computer system has a dictionary. So that is an internal file. Even if it is not mentioned in the problem, you have to think of yourself. So one internal file, that is the dictionary, that is of average, and two external files, document file and personal dictionary. So all are treated as average. Okay. Now it is given in the question that all the components are average or medium. If it is not mentioned in anything else in the question, you treat them as medium. Otherwise, it will be explicitly mentioned whether they are medium or low or high. It may be possible out of the 5, some may be low, some may be high, some may be medium. Like input may be of high complexity, output may be low complexity, query may be medium complexity. This file may be high complexity, this interfaces may be low complexity, it will be given. So only you have to use what? The different values. Now what I want to compute? UFP, on adjusted function point, because these are only straightforward. I have not used any multipliers, so that I will do later on. So we have to first find out the UFP, which stands for on adjusted function points. So what is the formula? As I have already told you, you have to take the 5 components. Then you have to multiply with the what? You have to multiply with their corresponding complexity factors. The complexity factors I have already given here. And since all are of medium, these values I will take. That is for input it is 4, for output 5, for inquiry 4, for file it is 10, and for interface it is 7. Let's use those values. So now let's see how many number of inputs. Please see how many? 2. So 2 into what is the complexity value? 4. How many number of outputs? 3. What is the complexity value for output? Complexity for value for output you can see. For medium it is 5, isn't it? For medium complexity it is 5. So that we will do here. See? So 2 into 4 we have taken, because 2 number of inputs and complexity is 4. Then how many outputs? 3. Complexity is 5. I have already told you. How many queries? 2. And what is the complexity? Already given 4. Then number of files. How many number of files? You can see only 1. And what is this complexity value? It is what? 10. And how many number of interfaces? You can see 2 interfaces. And what is the complexity? 7. So then solve this equation. So if you will multiply and then add, the value is coming to 55. That means the unadjusted function point for this spell checker software is coming to be 55. Now the next question is how you can get the adjusted function point. For adjusted function point, I have already told you we have to take one more parameter called as VAF, that is known as value adjustment factor. That depends upon some multipliers. Then that we'll see. Before that, a small example you can take. So Tom is starting a dental practice in a small town. He will have a dental assistant, a dental hygienist, and a receptionist. Okay. He wants a system to manage the appointments. When any patient calls for an appointment, receptionist will check the calendar and will try to schedule the patient as early as possible to fill in the vacancy. If the patient is happy with the proposed appointment, the receptionist will enter the appointment with the patient name and the purpose of the appointment. The system will verify the patient name and supply the necessary details from the patient records, including patient's ID number, etc. After each exam or each test or cleaning, the hygienist or assistant will mark the appointment as completed, add the comments or include the comments, and then schedule the patient for the next visit if it is required. The system will answer queries by the name of the patient and by date. Supporting details from the patient's records are displayed along with the appointment information. The receptionist can cancel the appointments also. The receptionist can also point out a notification list for making reminder calls 2 days before their appointments. The system includes patient's phone numbers from the patient records. The receptionist can also print out daily and weekly work schedules with all the patients. Question is calculate the unadjusted function point. So here first what we have to do. So we are running out of time. I'm just I have already identified the input, output, inquiries, files, and interfaces. You can just read the problem carefully. You can see that there are 3 inputs like patient name, appointment completed, appointments purpose, etc. And another one input cancel appointment. This is not simple or low. Here simple means low, average means medium, complex means high. So average, it is cancel appointment, it is of medium, and you have to use now the formula, isn't it? And then you have to see, because you see, for simple you just I can take one. For simple one, average, what are the values? Simple it is 3, and average is how much? 4. So that means how I got it? So it is 3. 3 into 3 how much? 9. And average is 4. 9 plus 4 is equal how much? 13. So total for inputs, the total value is how much? 13. Similarly, output you will get comments are very simple. But the preparing calendar, supporting details, appointment information, notification list, they may be treated as average. And but preparing this either the daily schedule or the weekly schedule is very much complex. So accordingly, we are given, and you can see that the values are how much? For output 457. So put the value here 457. This is 4. 5 into how much? 1, 2, 3, 4. 5 into 4, isn't it? So this is 4. This is 20. 24. And this is 7 into 2. So 24 plus 4, 14, 38. Like that. If I identify the inquiries, only one file is there. That is present data. That is of average. There are no interfaces required. So 0. And then what you have to do? You have to add this. How much you will get? 79. So the total what unadjusted function point for this problem is coming to be how much? 79. So in this way, small problems will be given. You have to find out the function points. Okay, the unadjusted function points. Now let's take up the other part. How to refine the function points. This is the, or how to adjust the function point. How can get the adjusted function points? We can get the adjusted function points from the unadjusted function points by using a parameter or factor called as VAF, value adjustment factor. Albrecht had found out 14 such characteristics. 14 general system characteristics are evaluated and they are used to compute a factor called as value adjustment factor VAF. These are the 14 general system characteristics like data communication, distributed data processing, performance objectives, heavy use configuration, transaction rate, online data entry, end user efficiency, online update, etc. So from research, Albrecht had found out these are the 14 characteristics or parameters, they affect the size of the system. So that's why they have found out these 14 system characteristics. So they are giving some values to these characteristics. Then you can find out the from these characteristics you can find out the VAF, value adjustment factor. The final calculation is based on, or the final adjustment adjusted function point can be found out by multiplying the unadjusted function point count into the value adjustment factor. So now let's see how you can compute the value adjustment factor. Then that simply will multiply with the unadjusted function point count. So in order to know the value adjustment factor, we have to know another parameter, because see, value adjustment factor is computed like this. There is a formula TDI into 0.01 plus 0.6i. And what is TDI? TDI is the total degree of influence. So first we have to know what do you mean by degree of influence. So that's why we want to know what is the degree of influence and what are the possible values. Perhaps these previous parameters or the previous 14 system characteristics, we have to know how each characteristic or how each parameter influences the system or influences the calculation of the system size or the software size. If that characteristic is not at all present or having no influence, we can give 0. If that characteristic have a very minimal influence, incidental influence, you can give 1. If it has moderate influence, you can give 2. If it has average influence, you can give 3. If it has significant influence, you can give 4. And if it is strong influence throughout the part software, then you can give 5. So like this. And if any question, the particular actually in the problem, the values will be given for the influence in the question. If it is not mentioned, you have to take as average normally. So average influence means 3. Okay. So accordingly, you remember. So these values I will use while calculating the VA. Now, I have already told you the values of what the influences for the 14 system characteristics. So these are the possible values. Now you have to stack one by one 14 characteristics. See whether it has very little influence or no influence or little influence or moderate influence. Accordingly, you give the values. You put these values from this list. Now evaluate each of the 14 general system characteristics on a scale ranging from 0 to 5 to determine what? To determine the degree of the influence of each system characteristic. So what is the value? It is shown here from 0 to 5. Then you have to add the degrees of influence for all the 14 general system characteristics in order to produce another parameter called as TDI, which is known as total degree of influence. Then we have to insert the value of TDI in the following equation to compute the value of the adjustment factor, to produce the value adjustment factor, or this is also known as this value adjustment factor. This is also known as a technical complexity factor, TCF. In some books you will find VAF, in some books TCF. So VAF can be computed as TDI into 0.01 plus 0.6. So TDI means what? This total degree influence. So let's take the simple case. If you are using suppose all the 14 characteristics are of average influence or medium influence. So what is the value? 3. That means for the whole system, what will the VAF? In case of TDI, I will put how much? 14 into 3. 14 into 3 means how much? 42. So 42 into 0.01 plus 0.65, whatever value you will get, that will be the value adjustment factor for the given problem. Otherwise, in the examination, it will given for all the 14 general system characteristics, which is having 1, which is having 2, which is having 5, this degree of influence that will given. If not given, take the moderate value, that is 3. So and then you compute the VAF. So this parameter or this factor called the value adjustment factor or technical complexity factor, it expresses what? It expresses the overall impact of the corresponding parameter on what? On the development effort. Okay. So now let's say we'll take a small example. The following VAF is calculated if the degree of influence for each of the 14 GSC descriptions is 3. So if all the 14 general system characteristics, they are coming to be, suppose they are 3, then the value how much will come, and they are all what? Average. Average means 3. So 14 into 3 is equal to how much? 42. So VAF will be how much? 42 into formula. See, formula TDI into 0.01 plus 0.65. So this is equal to what? VAF is equal to 42 plus 0.01 plus 0.65, that is coming to be 1.07. So now this is the value adjustment factor. So now how can find out the adjusted function point? Previously we have seen the unadjusted function point, isn't it? Please see my problem, previous problem. So how much it was we have got for the problem? Unadjusted function point is equal to how much? 55. And I have assumed that all the 14 general system characteristics, they are of medium influence. So the VAF is equal to how much we have found out? We have found out the value of VAF is equal to 1.07. So now the adjusted function point for the spell checker problem is calculated to be how much? AP is equal to UFP star VAF, where UFP is equal to, already I have calculated how much? 55 into VAF is equal to how much? 1.07. So coming to be 58, because this 55 is not the permanent one. This is a temporary one, unadjusted 155, because in this time we have not considered the overall influence of the general system characteristics. We have found out the overall general system value, their influence value, and multiply that, so that we can see that the value of the adjustment or the adjusted function point is coming to be 58.85. This we have got by multiplying the unadjusted function point with the value adjustment factor. Okay, this is how you can compute the what adjusted function point. So 1 or 2 questions may come from this point. Given a problem, calculate the adjusted function point for this problem. Okay. So here also, so it's given another, I think, example. See, like is given there are 14 parameters, 14 characteristics. Suppose data communication, its influence is 3, and distributed data processing is 0. Performance criteria 4, like this, all are given. So what? How to compute TDI? Just you have to see to what add all those things, isn't it? 3 plus 4 like this, 7, 10, 3, I think 13, 3, 16, isn't it? 19 and 3, 22, 3, 25, 30 and this 6, 36. So here the total degree of influence is coming to how much? 36, another example. So if this is the case, then what will be our adjusted function point for the spell checker? Instead of 42, put here 36, then solve the equation. Whatever the value you will get here, multiply with 55. That you will get the the adjusted function adjusted function point for this our spell checker problem. So these things will be specified in the question. If nothing is mentioned, you take the influence value as medium, that is 3. Okay. So this again for the second example I have taken. VAP will be now 42 is replaced with 36. This will be 1.01. So value is 55.55. So the value of the adjusted factor depends on this, what the influences of the general system characteristics. Okay. So another small example is given. It's a payroll application. So first we see the transaction to input and the transaction to input, amend and delete employee details, and EI that is rated from medium complexity. So here you see the input is given and its complexity is given, it's medium. Similarly, a transaction that calculates paid details from the timesheet data, that is also input. So see, this is input, this is also input, because this is also EI. EI means input. This is also input, and its complexity is high. A transaction of medium complexity that prints out pay to date details for each employee. So these two are obviously input. Third one is a what? Output. These are output of medium complexity. The complexity is given medium. A file of payroll details for each employee. A file is given. So file means it is what? It's a logical internal file. Its complexity is medium. And a personnel file maintained by another system is assessed for name and address details. So it is maintained by another system means this is the interface, EIF. What is the question? What will the function count for this? So here you can see that there are, you can see 2 inputs you can see here. The first 2 are inputs, isn't it? The serial number 1 and 2 are inputs, 3 is the output, 4 is a file, 5th is a interface, and you can see no queries are there, no inquiries are there. So how you can compute now? This is the table I have reproduced here for your understanding. You can see this medium and high complexity TI. First input is medium. Second complexity is high. So what will the values? Medium for internal input, medium is how much? 4. And high complexity is how much? 6. So medium EI is equal to 4 FPs. High complexity EI is 6 FPs. How many EOs? I mean outputs. See, output is how much? A transaction of medium complexity that prints out pay to date details for each employee, and EO of medium complexity. Output medium, you see how much? 5. So medium complexity output is 5 FPs. In the internal file, see, it is of again medium. This file is internal file, it is of medium. So for internal file, what is the medium value? 10. So 10 FPs. And what is about this inquiry? No inquiry. So we have not taken. And extra interface, yes. Interface we have taken, it is of what? It is a simple interface, a simple EIF. Simple means for interface simple is how much? 5 FPs. So we have given a simple EIF 5 FPs. So now we have given what? So total UFP is how much? Total UFP is equal to, just add those things, 30 FPs. This is what? On adjusted function point. So if you want what, if the previous projects delivered 5 function points a day, how to find out how much the time will be required? Implementing the above should take how much? If from your past experience you expect that you have seen that per day you can deliver 5 FPs, that means for this small problem, this payroll application will take how many days? 30 by 5. That means it will take 6 days to deliver the project. This is how you can find out the unadjusted function point and the time required. Similarly, if the influence values, degree of influence values will be given to you, you can easily find out the adjusted function point. Suppose we'll assume that all the all the influences are medium. Then for medium we know what is the value 1.07. If all the general characteristics are having medium influence, then the value will get VF is equal to 1.07. So how much you will get here? 30 into 1.07, that will give you the adjusted function point. If you will take the second example, that the value this degree of influence is 36. If it is 36, then VIP will be 1.01, and hence this adjusted function point will be 30 into 1.01. Then you can get the, isn't it? For 36 it is 1.01. So accordingly, the adjusted function point you can obtain as 30 into 1.01, whatever the value, that will be the adjusted function point. So in this way, okay. So this time has been obtained by dividing what 5 as per the previous experience, by dividing 30 by 5. If you will come, but that means by dividing the unadjusted function point. So if you want to know the exact things, because the adjusted function points, it's a better value, it's a more accurate value. So if you can compute the adjusted function point, whatever the value, then divided by 5, that will give you the accurate number of days required to deliver the program. Okay, so the average, the adjusted function point is what more accurate value than the unadjusted function point. If you want to know, get a accurate time, then it's better to divide the adjusted function point with this value like 5, which you got from the previous experience. That will give you the a better accurate time to deliver the project. This is how you can compute it. You can compute the unadjusted function points, adjusted function points, and the time required to deliver a software. This is this is what I wanted to talk. You have taken many examples. You can practice them. I have given some exercises here. Like the tic-tac-toe game, tic-tac-toe computer game software, the specification is given. So another aluminum repository software, the specification is given. A supermarket price scheme, a specification is given. So find out the adjusted function points. Okay, please find out the adjusted function points for these things and submit on Monday. So this is another one. So 5 exercises I have given. So please compute them and submit them on Monday. Okay, so today we have discussed the Albrecht IFPUG function point analysis, also discussed the steps to compute the function point count, presented the Albrecht IFPUG function point parameters or the general system characteristics. We have presented the Albrecht IFPUG function point parameters. We have explained the Albrecht or IFPUG function points counting with several suitable examples. This is what we have discussed today. So basically these things we have taken the number 1 book. Number 2, only the simple unadjusted function point, that example is there, but adjusted things are not here. Those things are in number 1. So both of these books you can see for the details on.
Sir, you have muted yourself.
Sir, unmute yourself, sir.
So this summary slide you have listened or where you are not able to listen? Please tell me from where?
Sir, from
Yes, from which slide? Sorry?
sir, after exercises, sir, when you have assigned assignments, sir, after that.
Okay, that means up to exercise you have listened.
Yes, sir.
Okay, then after that, my references, after that, thank you. So that is, then that's fine. After
Okay.
exercises, only references are thank you. That you can see
Yes,
from the
sir.
slides.
Yes.
Okay. So thank you very much. I hope I am clear now. Any doubts, please? Very, very important. You have to practice. So in order to give some power to you some exercise, I have given some exercises. Please practice them so that your doubts will be clear. Today I will put up these slides immediately so that you can practice yourself. Okay, and similar examples, exercises from other books also you may practice. Okay, thank you very much. We will take the attendance now.